In the previous videos, what we have done is we have understood what is an octant and we have solved a couple of problems based on an octant, correct? Now, the main point in any of the coordinate geometry part is finding the distance between 2 points. Now, here we have 2 points in any one of the 8 octants. That too, basically, we are talking about 2 points in space, right? So, how do we find distance between 2 points up in space? So, let's do the derivation, very simple derivation. Now, what you're seeing here, you have the coordinate axis, the 3x, y, z. The intersection point is the origin O. Now, in this, what we'll do, we'll take the 2 points, some random 2 points, okay? But before that, we'll try to do it with two simple points, which is in the first octant. You can take it up in any octant, any one of the 8, but here we'll look at only one octant, and that part is shown here. Fair enough? Now, let's say one point is somewhere over here, okay, and one more point is somewhere over here. So we have 2 points in the same octant. Now you can extend the same thing into any of the octants you want. Fair enough? So in this point, say this point, let's call it as x1, y1, z1. So instead of writing it here, so what we'll do, I'll write the first point, say this point is A. So A is given by x1, y1, z1. Alright? Now to get to point A, so this is point A. Now to get to point A, so what we do here along the x-axis, so let's name this one. Say this is the x-axis, alright? Say this is the y-axis, and say this is the z-axis. So we have x, y, and z. Now to get to point A, first we move this much along the x-axis, then we move this much along the y-axis, and then finally we are going to move so much along the z-axis, maybe something like this. Now try to understand this is in 3 dimensions, so you have to visualize the point. Fair enough? Now once you have this one, once you reach point A, now then what we do is we are going to construct a cuboid with A as one vertex and the other point what we are looking at as the opposite vertex. Now what we mean by that? Here we are going to construct a particular cuboid. So maybe something like this. So we are going to have a cuboid like this. And here we are going to have something like this. So we are going to construct a cuboid. Say the other point, say let's call it as B, let's call this as C. D is going to be somewhere over here, correct? Isn't it? Now if I have to make D, so what we'll do, so from here we'll take a point like this. So this is going to be D, say this is E, F, G and H. So point G is going to be x2, y2 and z2. Now just so you know what we are doing, we have point A. Point A we can get it by taking x, y and z. And point G, G is also another point. Now to get to G, what we do? So here first we are going to take this entire distance somewhere till here. Alright. Now or maybe till here somewhere. Then we are going to move across the y-axis something like this. Then we are going to move in the z. So z is going to be something like this. Okay, maybe here. Now, this is going to be the entire part. Fair enough? Now what we have x1, y1, z1, x2, y2, z2. We have both the points. What we are trying to calculate is we are trying to calculate the distance from A all the way till G, correct? Now, if you're moving from A to G, we are going inside the cuboid, isn't it? Now, to do this inside the cuboid part, we'll split this into two parts. Basically, we are doing two Pythagoras theorem, two triangles. With the help of that, we'll get it. Fine. And these two triangles, the right angle triangles, are going to be in two different planes. Clear? Now, the first one, what we'll do, we'll take triangle. So, what we are doing is first in the face ABCD, which is the bottom face, the bottom part. What you do, take triangle ABC. Okay, now when you take triangle ABC, what you can say, AC square is equal to AB square plus BC square. Correct? This is basically AC square. Now what you do, you join A and C like this. Here you got AC. Now we have to imagine the triangle in 3 dimensions. That is, now what we do, take triangle in triangle ACG. See that AC is along the base, CG is the height, and AG is going to be the diagonal within the particular cuboid, isn't it? So in triangle ACG, what you are going to get? You are going to get AG square is equal to AC square plus CG square, isn't it? This is what we have now. Now, but what is AC square? AC square is nothing but AB square plus BC square. Now, what you are going to get? AG square is equal to AB square plus BC square plus CG square. We have this, correct? According to coordinate geometry, what will be AB? So, AB is going to give us x2 minus x1, correct? And BC is going to give us y2 minus y1. CG is going to give us z2 minus z1. Normal coordinate geometry, nothing else. So what we are going to have now, AG square is the distance, isn't it? So the distance D or D square in this case. So you have D square is equal to x2 minus x1 whole square, y2 minus y1 whole square, plus z2 minus z1 whole square, or the distance D is equal to x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Everything under the root. This is the distance formula. Now, don't you think it's the same as what you did for 2-dimension distance formula? So it's going to be the same thing, but you have to add one more part, which is the z part. Now, the distance formula is the same, root of x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 a whole square. You add everything. Fine. Now, what if one of the points is at the origin? Then what is going to be the formula? Very simple. So here x1, y1, z1 is going to become 0. Correct? So let's do that one now. You're going to have the distance d will be root of x square plus y square plus z square. So this is going to be the formula. Now, for both 2 points or from one point being the origin, this is the formula what you have to use. Alright, so in the next video, we'll solve few problems based on this particular concept.